Before you watch any further, I want to correct something, because the real story here is actually more impressive than the exaggerated version floating around online. There is no urgent, unexplained, terrifying image that just came out of the Vera Rubin Observatory in the last few minutes. What's real and what genuinely deserves your attention is this. The telescope switched on for the first time roughly a year ago, and within about 10 hours of pointing at the sky, quietly discovered more new asteroids than most observatories find in months. It is now running as a fully automated real-time discovery machine, scanning the entire visible sky every few nights and flagging anything that changes anywhere within minutes. That is not an exaggeration. That is the actual documented capability of the most powerful survey telescope humanity has ever built, and it is only just getting started. Humanity has ever built, and it is only just getting started. The observatory is named after Vera Rubin, an American astronomer whose work in the 1970s and 1980s produced some of the most convincing early evidence that something invisible, something scientists still can't directly detect or fully explain, was shaping the way galaxies rotate and hold themselves together. That invisible influence eventually became known as dark matter. And decades later, when the National Science Foundation and the Department of Energy built a telescope specifically designed to study dark matter, dark energy, and the changing night sky in unprecedented detail, they named it after her. The observatory itself sits atop Cerro Pachon, a mountain in Chile chosen specifically for its dry air and extremely dark skies, two of the most important ingredients for any serious astronomical observatory. At its heart is the Simonyi Survey Telescope, an 8.4-meter instrument paired with something that genuinely has no equal anywhere else on Earth. The LSST camera, the largest digital camera ever built, capable of capturing images so enormous that displaying just one of them at full resolution would require roughly 400 separate 4K television screens arranged together. On June 23, 2025, the observatory released its first public images, and they were, by any honest measure, stunning. A composite view of the Trifid and Lagoon nebulae showed off the telescope's combination of enormous field of view and extremely high resolution in a single striking frame. But the images themselves, as beautiful as they were, weren't actually the headline. The real headline was buried in the fine print. During roughly 10 hours of test observations, taken simply to demonstrate the instrument was working correctly, Rubin Observatory had already discovered 2,104 never-before-seen asteroids in our own solar system, including 7 near-Earth asteroids, none of which posed any danger. To put that number in perspective, all other ground and space-based observatories on Earth combined typically discover around 20,000 asteroids in an entire year. This one telescope found over 10% of that annual global total in less than half a day, during what was essentially just a systems check. That result wasn't a fluke, and it wasn't the ceiling of what this instrument is built to do. It was a preview. Rubin Observatory's central mission over the next decade is something called the Legacy Survey of Space and Time, an ambitious program designed to photograph the entire visible southern sky, over and over again, roughly every few nights, for 10 consecutive years, building what astronomers describe as the ultimate time-lapse movie of the universe. Every few nights, the same patches of sky get rephotographed, and software compares each new image against a carefully constructed reference image built from everything the telescope has captured of that same region before. Any difference between the two, a new point of light that wasn't there previously, a star that's suddenly brightened or dimmed, an object that's clearly moved position, gets flagged automatically. And this isn't a process that takes days or weeks to produce results. Each meaningful change triggers a public alert within 2 minutes of the image actually being captured. Think about the sheer scale of what a 2-minute alert system like that actually enables. The vast majority of these automated alerts are expected to involve supernovae, the explosive deaths of massive stars, along with variable stars whose brightness naturally rises and falls, active galactic nuclei where supermassive black holes are actively feeding, and objects moving through our own solar system, asteroids, comets, and occasionally something rarer still. Because Rubin Observatory returns to the same patches of sky so frequently and processes what it sees so quickly, scientists expect it to become the most effective tool ever built for catching supernovae in their earliest possible moments, tracking asteroids well enough to properly assess which ones might eventually pose a real threat to Earth, and catching rare interstellar objects, the kind of rare visitors from beyond our solar system, while they're still fresh enough in the sky for other telescopes around the world to quickly turn and study them too. Over its planned 10-year survey, Rubin Observatory is projected to discover millions of new asteroids within just its first 2 years of full operation alone, an absolutely staggering leap over the total number of asteroids cataloged by every telescope in history combined up to this point. It's also expected to become the single most effective observatory on the planet for spotting new interstellar objects, the rare visitors from other star systems entirely. of which only 3 have ever been confirmed in the whole of recorded astronomical history. Given how much more frequently and thoroughly Rubin scans the sky compared to any previous survey, researchers genuinely expect that number to grow substantially over the coming decade, potentially transforming what has, until now, been an exceptionally rare category of discovery into something closer to a semi-routine occurrence. Beyond our own solar system, the scale of what this telescope is capturing is almost difficult to describe in ordinary terms. One video released using over 1,100 images captured by Rubin Observatory begins with a close-up of just 2 individual galaxies, then slowly zooms outward to reveal roughly 10 million galaxies visible within that single combined image. And astronomers have been clear that even that staggering number represents only about a 20th of 1% of the full number of galaxies, somewhere around 20 billion, that Rubin Observatory expects to capture over the complete 10-year run of its legacy survey. That enormous catalog of galaxies isn't just for show either. It sits directly at the center of the observatory's deepest scientific goal: understanding dark matter and dark energy, the 2 most significant unsolved mysteries in modern cosmology. Together, these 2 invisible, poorly understood phenomena are believed to make up roughly 95% of the entire universe, with ordinary matter, everything we can directly see and touch, including every star, planet, and person, accounting for only a small remaining fraction. Dark matter is the invisible material Vera Rubin's own original research helped reveal decades ago, the unseen mass that explains why galaxies rotate the way they do. Dark energy is something else entirely, the mysterious force that appears to be actively pushing galaxies apart from one another at an ever-accelerating rate. By repeatedly mapping the positions, shapes, and subtle gravitational distortions of billions of galaxies over 10 full years, Rubin Observatory is specifically designed to give scientists their best opportunity, yet to actually measure how dark matter and dark energy behave, rather than simply inferring their existence indirectly, the way researchers have largely had to do until now. More recently, the system has moved fully into live operation. In early 2026, Rubin Observatory officially launched its real-time alert infrastructure, the automated system now actively scanning fresh images against historical references and issuing those 2-minute alerts to astronomers around the world. Every single night the telescope operates. That shift from an impressive but essentially static set of first images back in June of 2025 to a fully functioning, always-on discovery engine constantly scanning the sky and instantly reporting anything that changes represents the actual moment. This observatory became what it was always designed to be, not just another powerful telescope capturing beautiful pictures, but a live, continuously operating early warning and discovery system for the entire visible universe, running every single night for the next decade. So no, there was no single terrifying image captured 3 minutes before this video went live. What's actually happening is quieter and considerably more remarkable than that kind of headline could ever properly capture. A telescope built specifically to notice everything that changes, anywhere, across the entire visible sky, checking back on the same patches of space every few nights for 10 straight years, has been running for roughly a year now, and it has already reshaped how quickly humanity can catch a newly forming asteroid, a freshly exploding star, or a rare visitor arriving from another star system entirely. The universe it's watching hasn't suddenly become more dangerous or more strange. We've simply, for the first time in history, built an instrument capable of actually keeping up with how often it changes. And it is only in the first year of a mission built to run for 10.